Question 1.4. Anhydrous magnesium chloride can be formed by the direct reaction between its elements. So I've got magnesium solid, chlorine gas making MgCl2 solid. The free energy change, so Gibbs free energy change for this reaction, varies with temperature as shown below. So I've got temperature in Kelvin and I've got Gibbs free energy change in kilojoules per mole. Use the data to plot a graph of free energy change against temperature on the grid opposite. Calculate the gradient on the line on the graph. So we've got to put free energy change against temperature. So if we look at that, so free energy change is down the y-axis and temperature along the x-axis. So Gibbs free energy change against temperature. So these values are coming down, so you actually have a look, it's minus 592 going down and the temperature is going up. So I've plotted with the origin here, so I can come down on this side and I can go across, and I've started from 240 and minus 592, and I've plotted the points on the graph and drawn a straight line. There's a mark for plotting the five points in the straight line and then working out the gradient. So that's the change in y divided by change in x. So you take 592.5. Here is the top point, high point, going down to minus 602. So take away minus 602. So minus 592 minus 602. And then, so the change here, you're actually measuring the change. So you can ignore the signs actually. You're just measuring the change. So the change between 593 and 602. And then you're measuring the change along the bottom from 240 to around about 298. So when you work those two out, it works out as 0.167. It's in kilojoules per Kelvin per mole. It's in kilojoules here because Gibbs free energy change is in kilojoules. Kilojoules per Kelvin per mole. So to get that into joules, we're going to have to multiply by 1,000. So to get kilojoules down into joules per Kelvin per mole, then a large unit value down into a smaller one you multiply by 1,000. Now, y equals mx plus c. The y value equals m, which is the gradient, multiplied by x, whatever's on the x-axis, plus c is a constant. So Gibbs free energy change delta G equals delta H minus T delta S. You could rearrange that slightly so you can see how it matches up with y equals mx plus c. Delta G is up the y-axis, so that's correct, equals mx. The x value is t. So T delta S, or delta S times T, minus, and then plus delta H. Well, the delta H is a constant. So you can see here, this is the y bit, delta G, T is the x bit, and so this minus delta S is the m. That's the gradient. So the gradient is minus T delta S. So delta S equals minus the gradient. So I'll reverse the sign now. So gradient equals minus delta S. Delta S is minus the gradient. So the gradient, now I've multiplied this by 1,000 to get it into joules per Kelvin per mole, is minus 167 joules per Kelvin per mole.